Hello everybody, I'm Hemashri studying in Sri Venkateshwara College of Engineering, currently pursuing my first year BE in Electronics and Communication. Today in this video, let us know about nanomaterials in applied chemistry. In this video, I'll be covering introduction, size-dependent properties of nanomaterials, surface area, catalytic properties, conducting properties, and that is further divided into electrical and thermal conductivity. Let us start with the introduction. A nanomaterial refers to a material with at least one of its dimension in nanoscale, and the size of nanomaterials varies from a nanometer to 100 nanometers, and the nanometer is 1 billionth of a meter, that is 10 to the power minus 9 meter. When it comes to the length, it is approximately equivalent to 10 hydrogen or 5 silicon atom aligned in a line. A nanotechnology has become an interdisciplinary science involving chemistry, physics, material science, biology, and medicine. Nanotechnology is the study of all the phenomena and processes involved in the synthesis, properties, and applications of nanostructures and nanomaterials. Any nanomaterials of nano size with its properties distinctively different from its bulk form are considered as nanomaterials. Size-dependent properties of nanomaterials. These nanomaterials exhibit several size-dependent properties like surface area, catalytic properties, conducting properties. The first one, surface area. Many physical and chemical properties of a material depend on its surface properties. If a bulk material is subdivided into individual nanomaterials, the total volume remains the same, but the collective surface area is greatly increased. Example, the collective surface area of cube is 6 meter square. If this cube is progressively cut into smaller and smaller cubes, the surface area will increase to 6,000 kilometer square. Thus, surface area is enormously increased on moving from bulk to nanoscale. Properties like catalytic activity, gas adsorption, and chemical reactivity depends on the surface area. Therefore, nanomaterials can show specific surface related properties that are not observed in bulk materials. Example, bulk gold is catalytically inactive, but gold nanoparticles are catalytically very active for selective redox reaction. Gold nanoparticles greater than 20 nanometer is purple color, and gold nanoparticles between 10 to 20 nanometer is red in color. The second property, that is catalytic property. The catalytic property of materials depends on particle size. If the size of the particles reduces from the bulk to nanoscale, the surface area increases. That leads to very high catalytic activity of the same material. Example, bulk gold in catalytically inactive, but gold nanoparticles are catalytically very active for selective redox reaction. And here is a chart which depicts about the nanomaterials as catalysts. Its types are carbon, metal and oxides, and others, and its characteristics. In carbon, it is fluorine or carbon black, graphite, etc. In metal oxide, it is cobalt, aluminium, iron, while others means it is quantum dots or clays. Characteristics are adsorbent, wide range of applications, high surface area, range of possible chemistries, high catalytic activity, natural and synthetic. Coming to the last property, that is the conducting properties. Nanomaterials show different conducting properties like electrical conductivity, thermal conductivity, photoactivity, etc. Electrical conductivity. The electrical bands in bulk material are continuous due to overlapping of orbitals of billions of atoms, but in nanoparticles, very few atoms or molecules are present, so the electric bands become separate, and the separation between different electric state varies with the size of nanomaterial. Hence, some metals which are good conductor in bulk become semiconductors and insulators as their size is decreased to nano levels. Thermal conductivity. As the size of the material decreases to nanoscale, their melting point decreases because surface atoms are in contact with only few atoms in nanomaterials and require less energy to overcome intermolecular forces. Example: 3 nanometer cadmium selenide nanocrystal melts at 700 Kelvin compared to bulk cadmium selenide at 1678 Kelvin. Coming to the conclusion, in bottom-up approaches, desired nanomaterials are built from the bottom by orderly assembly of growth species like atoms, molecules, ions. This approach has advantages like the methods are simple, versatile, and economically viable. Method provided better control over chemical composition, size, microstructures, and aspect ratio of nanomaterials. Nanomaterials with less defects and high purity were synthesized. This is a flowchart that depicts about nanomaterial synthesis through physical, chemical, and biological processes. Hope you understood the video. If you find this video helpful, please do like, share, and subscribe. Thank you.